looking at the student in red, you notice that they start right about middle level of anxiety, and it kind of goes down at first because maybe the questions are not too hard. Then the questions start getting a little harder, and maybe um, the nerves are kicking in. Then there's like a really an easier question, a slightly easier question that kind of increases the confidence or decreases the testing anxiety. And then we see going from there, the questions maybe get, um, stay a little easier for a bit, and then we start to get relaxed, and then the questions start getting harder again, harder and harder. So they're running into questions, the students running into questions that they are less and less confident about. And then maybe right around here at the 50-minute mark. So these are the minutes and increments of 5 along the bottom here. So this is tracking along with time going throughout the test. So right about here, about 50 minutes into the test, more than halfway through, you see that anxiety level just jump right up from just above 7 to an 8. And then within 5 minutes, it increases to a 9, comes back down a little bit, jumps up again, and then stays around the same, right at a 9. And then during the last uh, 5, well, 10 minutes of the test, from 75 to 85 minutes, the student's at a full 10. Okay, so I'm imagining that, once we get to a certain point where the questions are getting increasingly difficult, maybe at the 50-minute mark, um, the students may be realizing like, I'm more than halfway through this test. I haven't answered that many more questions successfully. And so that anxiety is going to take hold and kind of take that student into almost like a downward spiral where the anxiety level is just climbing and climbing faster and faster. Then it'll reach a peak. Maybe there's a slightly easier question, or maybe the person's able to talk themselves down and say, no, look, I've got, I've still got, in the last 5 minutes, I was able to answer a couple more questions. I feel a little better about that. And I still have a good 20 minutes left to be able to get through this. Um, Now remember, the 85 minutes is actually 75 minutes plus 10 minutes of overtime when you guys take it, with me at least. Um, so, the students at this point, like, well, I still have, 20 minutes that I could make something happen here. So I'm just going to relax a little bit. But then they go on to the next question maybe, and it's a really hard one. And so right away, they just pop right back up to that 9. And then, the questions are harder. They're at the end of the test. The concepts have been building throughout. And, the student's just not able to talk themselves down anymore as the clock keeps ticking. And then within the last few minutes, their anxiety level is so high, just because they're losing hope, and they're completely panicked. That's probably about what happened there. So I would guess that the student did not do well on the test at all, maybe an F or a D. And then looking at the blue student, so this is student B, and you can just see that the overall anxiety level for student B is much lower. Well, it's lower. I mean, there are some points where the anxiety level gets kind of high, but it never goes above a 7, right? And it only stays up there for a brief period. And then instead of getting more than halfway through the test and having a spike in anxiety, you see that anxiety level just declining steadily and, at an exponential rate there, going downward. So like an inverse exponential. And then at some point, right in that last 10-minute mark, it's like, oh, I'm almost done here. I finished all the questions. Um, I feel like I've done pretty well here overall. And then uh, kind of just a drop down when they realize, oh, I've answered all the questions and I still have a good 10 minutes of overtime if I want to try to answer a couple more things or check my work, right? And so then that continues steadily down until the last 5 minutes. Maybe at that point, the student's really feeling like, I think I've done my best on this. I still have a good 5 minutes to kind of look over things. Very calm, the worst is over. And so I would guess that that student did at least a B or an A, right? So that's where this picture came from, was my imagination. Um, Also paired with me trying to make it fit toolkit functions, since we've been learning about toolkit functions and how to shift the original parent functions up or down, left or right, or how to flip them, how to scale them, and all of that. So we've been learning about how to not only transform, but how to write the equations to match some graphs. So they should be no more difficult than the ones you've been seeing in your assignments. Um, so we're gonna go through how to get the piecewise functions for each of these. So here's the red. We're gonna focus on the red first. So in the red picture, um, let's pick a couple of points for this first piece. So first thing I want you to notice is that we're gonna call this first one a of x, just because it's student A, it's a function of x, and we're gonna let x be minutes, okay? That have passed since the start of the test, right? So x is going to have a domain from 0 to 85, you could say. And we're starting with this first leftmost piece. And as I do my pieces, I'm going to be building, each piece here. And how many pieces will I have? Well, from here to here is one piece. Okay, there's one. From here to here is a second piece. Then third piece here, fourth piece here, because it's from this point to this point, fifth piece here, and a sixth piece here. Okay, that may seem like a lot, but I bet you we'll get through it quicker than you might think. All right, so we're going to do this first piece from, I think I'll use blue for the first piece. We have a closed dot at 0, 5, and let's do an open circle from at 20, 4. Now, you might be looking at it and saying, well, that's a closed dot. Yes, it is. But I'm going to let that closed dot be filled in, or the open circle for my blue piece be filled in with the next piece. So that's why I'm calling it an open circle for now, because when I write out my intervals, it'll make sense, I think. So I'm going to call this the function a of x. It's going to be in pieces for different intervals of x. So I got my big bracket here. And for the first piece, which I'm using blue for just to make it easier on us visually, I'm going to put x in between what two values. Okay, so it may be easier if you just highlight along the x-axis where that first blue piece is covering on as far as x values. So I can see it's going from 0, and I'm going to include that because it's a closed dot there, and then up to 20. Okay, so what is this first piece? Well, it looks like a line. So let's write down y equals mx plus b, the slope-intercept form of a line. And I can quickly identify the slope, but be careful here because your horizontal scale is in increments of 5. Notice it's going 5, 10, 15, 20, and so on. Whereas the anxiety scale is going in increments of 1. Okay, so to find the slope, which is m, which is rise over run, or the vertical change over the horizontal change from one point to another point on that line. Now I can see that if I go from left to right, it's going down. So this is a decreasing line. It should have a negative slope, and we'll just make sure that we're thinking correctly that it's negative in the end. But starting from that leftmost point at 0, 5, I'm going to go down 1. Okay, so I went -1 for the rise. Then I'm going to go to the right 5, 10, 15, 20, and that was in the positive direction on the x-axis. So my slope is -120. So now I can replace that in the y equals mx plus b. Okay. Now I just need the b, the y-intercept. Now I can actually see that it goes through 5. So that makes it easy. This first piece is done. Okay, let's change colors and move on to the next piece. Okay, so the next piece also looks like a line, this time an increasing line. So I'm expecting to see a positive slope on this one. And so once again, I'm writing down y equals mx plus b. The slope, let's find the rise over run from the point 20 comma 4 to the point 30 comma 6. Even before I do that though, I almost forgot. I do want to look at the interval here from 20 to 30. Let's put that down. So the x interval is going to go from 20 and including 20 up to 30. And there's an open circle at 30. Okay, so now I got my interval down. Now I'll focus back on the rise over run. So from the point 20 comma 4 to the point 30 comma 6, I'm going to rise up 2 units. So that's plus 2, positive 2 in the top. Then the run is 5/10, which simplifies, since I can divide 2 into both of these numbers, it simplifies down to 1/5. Now what about the b? Well, I can't see where it intersects the y-axis, but if I were to extend this in using the rise over run and just pretend that the line kept going backwards farther, going down 2, and then if I went down 2, I got to go backwards. What was it, 20 down to backwards 5, sorry, 10, backwards 10. Yeah, down 2, backwards 10, down 2, backwards 10. Or if I even did down 1, backward 5, down 1, backward 5, down 1, backward 5, down 1, backward 5. So you can see that I am hitting the 0 on the y-axis. And you can see that line would extend like that. All right, so we're going to say that b is 0. So that means that my second piece is also done. It's 1/5 times x plus 0, but we don't need to write the plus 0, so we'll just take that part off. Okay. Another way you could have figured out what the y-intercept is to simply use one of the two ordered pairs to substitute for x and y and then solve for b. So I'll show you what that would look like. So if you don't want to use the visual approach, this one's actually going to be more accurate in some cases. So I'm going to just write down what I had was 1/5 x, right, plus 0, right? So that's my equation. I don't need the plus 0. Now I'm going to take the coordinates from the point 20 comma 4 and substitute them in. So for the y value of 4, oh, wait, I do need the b because I haven't figured out that it's 0. I'm showing how to find that it's 0 using this method, sorry. Okay, so 1/5 times x plus b, but x here, we're going to plug in 20. And then 5 goes into 24 times. So now I have 4 equals 4 plus b. And if I solve for b by subtracting 4 from the right, I have to also subtract it from the left. And then I get 0 equals b. Okay, so that's an example. That's just showing how to do it. Instead of counting down and backwards, you can just plug in the coordinates from one of the points. Okay, now let's move on to the next piece. Okay, so we've already got 2 pieces down. That's pretty good. So now we're going to be looking at this parabolic shape here from here to here. Okay, looks like a quadratic. And thus the intervals of x for this one are going from 30 up to, what is that, 50? Yeah, 50 right here. Okay, 30 to 50. So let's write that down for this third piece from 30. And are we including it? Yes. Okay, because there's a closed, you don't see an actual dot, but there was an open circle on the previous piece right at x equals 30, and then the drawing picks up right on x equals 30. So yeah, it's including 30 for this next piece. And it's going up to 50, and it's including 50. All right, now because this one's going to be quadratic, we're going to approach this one differently than the last two. We can see that the bottom, the lowest point of the parabola here, which would be our vertex, is at the point 35, comma 5. So using vertex form of a quadratic equation, we can write y equals a times x minus h quantity squared plus k, and just substitute in the h of 35 and the k of 5. Now, the only thing we still need, though, is that a, that coefficient there. So I'm going to use one of the other points on the parabolic shape. So let's use this one here. Since it's going through two grid lines, nice and easy to identify the coordinates. So it's going through x equals 45 and y equals 6. So now I'll come to what I had so far, and I'm going to replace the y with 5, the x with 35. Oh, sorry, 45 is what I should have put there. 45. I think I was looking at the wrong thing here. Hold on, hold on. That's the vertex. We don't want to use the vertex anymore. We already used the vertex. We need to use something else for this part. So we're going to put in 6 for the y because we're coming from the point 45, comma 6. 6 for the y. Then 45 for x. And now we'll just solve for a. And we'll be done with this piece. 6 equals a times, what is that, 10? 45 minus 35 is 10 squared plus 5. So 6 equals a times 100 plus 5, or better way to write this would be 100a plus 5. Then we'll start doing our solving because we want to get a all alone on one side of the equals. So we'll subtract 5 from both sides here. Then we'll have 1 equals 100 times a. Then to get a alone, we just have to divide both sides by 100. And now I'm done. So now I can just replace the a in my piece, not that piece, the piece right under it, this one right here. Put in 1 over 100. And now this is that third piece that we need to put in to our piecewise function up here. We're doing pretty good. We're already halfway through. Let's go get my color here. So 1 over 100 times x minus 35 quantity squared plus 5. All right. I think there was something else I just thought of saying here, but I guess I'll just keep going because I don't remember what it was. Oh, I know what it was now. I was going to say that we can also just do a quick check because looking at this parabolic shape, it looks concave down, or rather the ends would be pointing up, so it's opening upward. So it should have a lead coefficient that is positive. So the fact that we have our A as a positive value is aligning with what I'm seeing in my picture. So I just wanted to point that out. All right, so let's now go on to the next step. We're going to be looking at a new segment. Okay, we'll need a new color. What shall we use? I don't know. We need something with good contrast value. Maybe I can circle back to blue. Yeah, these are the ones I don't know if we should use. Let's just stick with blue. All right, so I'm gonna do this piece now. It has an open circle at 50, 8. Then it goes up and comes back down and has a closed circle at 60, 8, right? So my X values are going from 50 to 60 here. And since I have an open circle on the left, I want to be careful to not use less than or equals, just a strictly less than sign on that side, and then I can use the greater than or less than or equal sign on the right portion. And that looks like an absolute value function with a negative lead coefficient because it's opening downward. So I'm guessing that I should do y equals a times the absolute value of x minus h plus k, because it's similar to the quadratic, but now instead of a square, we have an absolute value. But same kind of idea. We want to see the vertex, which is at, the vertex is at 55, 9. So let's start by placing those values in for the h and the k. Then we'll use another ordered pair. Doesn't matter which one. I'll just use 50, 8. So I'll put in 8 for y, 50 for x, and solve for a. So now we have the absolute value of -5 when we simplify, and the absolute value of -5 is just 5. Remember, absolute value just means the distance from 0. So now I have 5a plus 9 there, and I'm ready to start solving. So let's go ahead and subtract 9 from both sides. That gives me -1 on the left, 5a on the right. Then divide by 5 on both sides so that we get a equals -1/5. Okay, I was expecting it to be negative since my V shape is opening down. So this aligns with what I was expecting. Okay, and I can go ahead now and write my fourth piece. So it's -1/5 times x minus 55, absolute value plus 9. Okay. Okay, we're almost done. We have 2 more pieces, but they're both constant functions, so this will go really quickly. All right, so my next piece is, let's look at the interval of x. So this piece right here for the values x of 60 to 75. Okay, so I will use green again, and I'm just going to put the x values from 60 up to and including 75. Then the y value that is always the same is 9. So I'm done with that. That was it. Pretty nice, right? Y always has to be 9, so that's it. Then the next piece, the final piece here has an open circle there, closed dot there. Even though you don't see a dot, you still call that a closed dot. And the value of x is starting at 75, not including it because it was already included on the previous piece, and then going up to and including 85, which is the end of the test. And during that time period, the anxiety level is at a 10. Okay, so that's it. We're done. Really kind of fun, I think, if you've taught yourself how to do this. Um, it feels very empowering to be able to get through all that. Okay, now the second piece here is, I'm sorry, the second graph here, the blue part. This one has how many sections? Let's see. We have 1 here, 2 here, 3 here, 4 and 5 pieces. All right, so we're going to do 1, 2, 3, 4, 5 pieces for this one. And that first one looks like a constant function, so that'll be nice and easy. We can see that it's staying, the anxiety level is staying at a 3. And during that period, x is between starting at 0 and going up to, let's make this an open circle, up to 20. Okay. Then the next piece, which is going to pick up where we left off with the previous part with a closed dot on the left, and then we'll make it an open circle again on the right, just to kind of stay consistent. We're going to go from 20 x values, 20 up to, what is the x value here? The x interval is from 20 to 40. Okay, and that is another line. I can see the 2 points, 20 comma 3 and 40 comma 4 to help me with my slope. So I'm going to do my my y equals mx plus b. And I'm going to count my rise over run. So the rise is up 1. And then to the right, 5, 10, 15, 20. And then the y-intercept, I can either choose to visually count down 1 and backward 20, 5, 10, 15, 20, which would get me at a y-intercept of 2. Okay, so that's one way to do it, pretty quick and simple. Or I could have chosen to leave the B like that and plug in one of the ordered pairs that's on this segment, or that this segment connects to. And so if I put in the 20 comma 3, for instance, I could put in 3 for y, 20 for x, then the 20s cancel to 1, and I can subtract b on from both sides, or I'm sorry, subtract 1 from both sides to solve for b, and then I get b equals 2. Okay, so either way, I got b equals 2 for that piece. So I'm going to go in and write my second piece. Remember, we'll call this one b of x equals all these pieces. So my second piece is 1 over 20 times x plus 2. Okay. Now let's pick up with a closed dot here. And then we've got a parabolic shape. It's opening down, so I'm expecting the lead coefficient to be negative. And there's an open circle starting in the next part, so we'll have a closed, we'll think of it as a closed dot on both ends of this. So this is x going in between and including what are the x values here from 42 all the way to 75. Okay, so from 40 to 75, we've got this parabolic shape. So we're going to use vertex form again because I do see that the vertex is pretty easy to identify in this image. The vertex goes through two grid lines. So we know for sure what those coordinates are. If we didn't, it wouldn't be a good idea to use the vertex. You'd be better off using some other points. But I'm going to use that point right there, which is the vertex at 55, comma 7. So y equals a times x minus h quantity squared plus k is the vertex form in general. Then I'm replacing the h with 55 and the k with 7. Now I just need to use another point to plug in so I can solve for a. So let me get another point through some nice grid lines. How about this point here? I could have also used 40, comma 4, but I'll use this one instead. How about 70, comma 4? So plugging that in, 4 for y, 70 for x. Simplifying, 70 minus 55 will be 15. And then 15 squared, actually I don't know what 15 squared equals. Let's do a quick 15 times 15, 25, carry the 2, 75, then 15, 5, 2, 1, 2, 225. So I have 4 equals 225a plus 7. Then I'm going to subtract 7 from each side so that I get negative 3 equals 25, or sorry, 225a. Then I can divide by 225. So that I get a is equal to negative 3 over 225, right? So writing this down, I got negative 3 over 225 times x minus 55 quantity squared plus 7 as my third piece. And I'm just going to double check that that is correct from what I did when I made this graph. If I can find my cursor, it's blending in. There we go. Let's see the piece. Negative 3 over 225. Yeah, that's right. Okay, we're good. Finally, we have like two more little pieces right here. They're both linear. So let's knock those out. So now we're interested in let's use this color here. We'll go from this open circle at 75, comma 1, and then this closed dot at 80, comma 0. So our values, open circle at x equals 75, closed at 80. And I'm probably writing that a little far down. I'm going to need some room for my final piece, which is a constant function. So that should go nice and quick. I'll just move this up. And then we are doing a y equals mx plus b again, where we're going to start with the rise over run. So the rise here would be down 1 and to the right 5. And then to find the y-intercept, let's just plug in We can plug in either one of these. Let's do 80 comma 0. So we'll put 0 for y, 80 for x, then 5 goes into 80, I believe 16 times, because 5 goes into half of 80. 5 into 40 would be 8, right? Yeah. So this is going to be negative 16. And then if I add 16 to both sides, I get b equals 16. So now we have negative 1/5 times x plus 16. And our last piece, notice that the anxiety level is at 0 for that last part there. So we just need to say 0 for x values starting after 80 and up to and including 85. And we're done. All right. Well, that was fun. I hope you enjoyed it and feel like you learned something awesome from this, or at least you feel like you could maybe figure out how to do something like this for yourself, because you're going to do your own story and create your own piecewise function. You don't have to do quite so many pieces. You can if you want, but if you have at least 3 pieces, that's fine. And you're just going to need to use at least 2 of the toolkit functions when you're building this. So good luck.